We see it every single day. It warms our skin, drives our weather, and paints our sunset in brilliant shades of orange and gold. To us, the sun feels like a familiar, peaceful neighbor, a perfect glowing yellow ball in the sky. But some of the most basic things we know about the sun are completely wrong. It isn't yellow, it isn't burning fire, and it isn't sitting still. Right now, our parent star is racing through the Milky Way at incredible speeds, powered by a magnetic engine so violent it can disrupt satellites, radio communications, and even power grids from nearly 150 million kilometers away. Today on Exolodem, we are pulling back the cosmic curtain from its true color to the incredible journey of a single photon. Here are some of the most mind-blowing facts about our sun. Let's start with the fact that sounds completely wrong. The sun isn't yellow, it's actually white. If we were an astronaut floating in the vacuum of space aboard the International Space Station, the sun would appear as blinding white beacon. So why does it look yellow from Earth? The answer is our atmosphere. When sunlight enters Earth's atmosphere, a process called Rayleigh scattering occurs. The atmosphere scatters some of the shorter blue wavelengths of light in every direction, which is why the sky appears blue. The scattering changes the color of the direct sunlight reaching your eyes, making the sun appear slightly yellow, especially when it's lower in the sky. But it gets even stranger. If scientists measure the sun's spectrum, they find that its peak emission occurs at the blue-green part of the spectrum at roughly 500 nanometers. Of course, the sun emits every visible color at once. Combined together, these colors produce what we perceive as white light. So, scientifically speaking, the sun is a white star that shines across the entire visible spectrum, even though our atmosphere often tricks us into seeing it differently. If the sun isn't burning like a giant ball of fire, then what powers it? Unlike a campfire, the sun doesn't shine through chemical combustion. Instead, it produces energy through nuclear fusion. Deep inside the sun's core, temperature reaches around 15 million degrees Celsius, while pressures climb to roughly 250 billion times Earth's atmospheric pressure. Under these extreme conditions, the hydrogen nuclei fuse together to form helium, converting a tiny fraction of their masses directly into energy. Every second, the sun fuses around 600 million metric tons of hydrogen into helium. In the process, roughly 4 million metric tons of matter are converted directly into pure energy, exactly as described by Einstein's famous equation E is equal to mc square. That energy is born as high-energy gamma-ray photons. Now, here's the unbelievable part. Once a photon is created, it doesn't simply fly out of the sun. Instead, it enters one of the slowest traffic jams in the universe. The sun's interior is an incredibly dense sea of plasma. A photon consistently interacts with charged particles, repeatedly being absorbed and re-emitted in random directions. Physicists describe this as a random walk. Although light travels at nearly 300,000 kilometers per second, it can take anywhere from hundreds of thousands to nearly a million years for the energy created in the sun's core to finally reach its surface. And once it escapes, it races across the vacuum of space to Earth in just 8 minutes and 20 seconds. The sunlight warming your face today may have begun its journey long before the first human civilization ever existed. Most spinning objects in space bulge slightly around their equators. Earth does, Jupiter does, even rapidly floating stars do. But the sun is different. Despite measuring roughly 1.39 million kilometers across, large enough to fit around 1.3 million Earths inside it, the sun is one of the most perfectly spherical natural objects ever measured. If you somehow shrank the entire sun down to the size of a standard beach ball, the difference between its equator and its pole would be similar and smaller than the width of a single human hair. Its immense gravity is so powerful that it pulls its fluid body into almost unbelievably perfect sphere. The sun doesn't have a solid surface. It's an enormous ball of plasma. That means it doesn't rotate like Earth does. On Earth, every location completes one rotation every 24 hours. On the sun, different regions rotate at different speed. Astronomers call this differential rotation. Near the equator, the sun completes one rotation in about 25 Earth days, Closer to the poles, the same rotation takes roughly 35 Earth days. Imagine driving a car where the middle moves faster than the front and back. That's essentially what is happening inside our home star. This uneven rotation twists and stretches the sun's magnetic field over an approximately 11-year solar cycle, creating sunspots, solar flares, and powerful solar storms capable of launching billions of tons of charged plasma into space. The sun also consistently releases a stream of charged particles known as the solar wind. Every second, this flows and carries vast amount of material outwards, extending far beyond Pluto. When it collides with Earth's magnetic field, it produces breathtaking auroras. But during especially powerful events, it can also interfere with satellites, GPS systems, radio communications, and electrical power grids. We often picture the solar system as a family of planets, but in reality, it's almost entirely the sun. Our sun contains an astonishing 99.86% of all the mass in the entire solar system. Everything else, Jupiter, Saturn, Earth, the moon, every asteroid, every comet, makes up only the remaining 0.14%. Its gravity completely dominates our cosmic neighborhood. But despite holding the solar system together, the sun isn't standing still. At roughly 4.6 billion years old, it is about halfway through its life. Right now, it's orbiting the center of the Milky Way at roughly 220 kilometers per second. Even moving that fast, one complete trip around the galaxy takes approximately 230 to 250 million years. Astronomers sometimes call one orbit around the Milky Way as a galactic year. This means during its entire lifetime, our sun has completed only about 20 galactic orbits. Our entire solar system has circled the galaxy only 20 times. The next time you step outside and look up at the sun, remember what you are really seeing: a nearly perfect sphere of white plasma, a star powered by nuclear fusion instead of fire, a cosmic engine whose light may have spent hundreds of thousands of years escaping its own interior before reaching your eyes, and a massive object that anchors nearly all the mass in our solar system while carrying us on an incredible journey around the Milky Way. We are fortunate enough to exist during the stable Middle Ages of this medium-sized star. In about 5 billion years, the sun will exhaust the hydrogen fuel in its core and expand into a red giant, almost certainly engulfing Mercury and Venus and possibly Earth. But until then, it remains the reason life exists on our planet at all. If you enjoyed uncovering the hidden secrets of our universe, be sure to subscribe to Exolodem for more deep dives into space, science, and incredible mysteries of the cosmos. Thanks for watching, and I'll see you in the next one. Till then, you can watch this video. Thank you.